Hey, let's implement the class that will power the peer-to-peer network in this blockchain application. This is going to allow multiple blockchains to interact with each other in a peer system, and we're going to leverage the publisher-subscriber pattern. And to do this, we're going to use the capabilities of Redis. So to work with Redis in Node, there's a very handy module named Redis. So let's install that on the command line. We're going to use npm I Redis at version 2.8.0 as of this course, and we'll use the save flag. Cool. With that installed, we're going to make a pubsub.js file at the root of the project. So that is pubsub.js, which is short for publisher subscriber. So let's recall the main definition of the publish subscribe pattern. This is a kind of messaging pattern where you can either be a sender or a receiver in the system. If you're a sender, you're going to publish messages on specific channels. If you're a receiver, your job is to listen to messages on those channels. The advantage of this pattern is that you don't have to know the addresses of other nodes in the network, so there's less overhead in terms of keeping track of that. You only have to worry about publishing to channels when you want to inform others of something new. Likewise, you only have to subscribe to specific channels to receive incoming messages on the channels that you're interested in. We're going to create this pattern with a new pubsub class, but first we're going to require the Redis module from its location at the Redis node module directory. Then we'll define our pubsub class. Notice that it's camel cased, the P is capitalized, and the S is capitalized. Let's give it its constructor. So it has the constructor method, and within this pubsub class, we're going to create two local fields for a pubsub instance. One will be called the publisher, and the other will be called the subscriber. And both are going to be results of the redis.create client function. We'll create a publisher, which is the result of redis.create client. And we'll also make a subscriber, which is the result of redis.create client. Awesome. The reason we want both a publisher and a subscriber in one class is that we want the pubsub instance to be able to play both roles in our application. It can be a publisher when it wants to broadcast a message to all the interested parties in the network. Likewise, as a subscriber, it should be listening on specific channels for new messages. All right, to begin, let's define the channels for the overall pubsub implementation with an overall channels map at the top of the file. We'll make a constant called channels. This will be set to an object, and the very first channel we'll define is one called test. So the key will be in all caps test, and the value for that will be test as well. Nice. Next, let's take care of the code to make a pubsub instance act as a subscriber. To do this, we have the subscribe function within the subscriber Redis client. So the subscriber is going to call this subscriber.subscribe, and then we provide a channel to subscribe to, which in this case is the channels.test string channel. Nice. Now the subscriber will have the ability to receive any messages that are published to the test channel. Still, the subscriber needs to be equipped to handle those incoming messages. We're going to need to configure a way for it to receive those messages. To handle these messages, we can attach a callback function to the subscriber that will fire whenever it receives a message event. So it's configured like this subscriber.on, a string of message, so that represents the message event. And the second parameter is a callback function, which fires every time this message event is received. So here we have the callback, and this callback takes two parameters. One is the channel which got fired, and the second is the message that it's receiving. However, rather than writing all the code to handle the pass channel and the pass message right here in the constructor, let's make a helper method in the actual class called handle message. So this will be called handle message. This is going to take a channel and a message. All right, and then our subscriber callback, the result is going to call this.handle message, and it'll pass in the channel and the message that it has in the overall function. Cool. So let's also place these on their own line so that way it's more easily visible. All right, nice. And now within this handle message function, well, let's do something simple. Let's log the message that was received for now. We'll console.log a template string, which says message received, period. And then we'll specify which channel that got fired, and then the message that actually got sent on the channel. So again, use backticks, use the $ curly brace syntax for the interpolation of these channel and message variables. Cool. So this gives us enough already to experiment with. At the bottom of the file, let's make an instance of this pub sub class. We're going to call this test pub sub, and this will be a new pub sub instance. So a new instance of the pub sub class. And then the goal with this test pub sub instance is to receive a message on the test channel, and then log that message with the handle message function. That way we can check if our subscriber publisher pattern is actually working. So luckily, the test pub sub also has a publisher. The publisher of the pub sub class has a handy publish function within it. And this publish function takes two parameters. We can call test pub sub .publisher to access the publisher, and then .publish. And we want to publish on the channels.test channel. And for our string, it has to be in a string format, so how about the string of foo? Cool. And then the result that we're hoping for is that the handle message function of the subscriber logs that a message was received on the channel test with the message foo. All right, cool. So head to the command line, and then we're going to want to start the Redis server. Now, if you don't have Redis installed already, head to the previous lecture where you're going to find detailed instructions on installing Redis for your operating system. Okay, Redis server should have been installed, or rather configured globally on your operating system. So Redis server should be available. There's the daemonize option, spelled D-A-E-M-O-N-I-Z-E. And the option we want to pass is yes. And this will fire Redis server in the background. All right, cool. With the Redis server available, we can fire node pubsub.js, and we should have clients created based off of that Redis server. Now, as you do so, the output might not be what you were expecting. When node pubsub.js is fired, we get an empty output, which is weird because we configured it to handle the message. But eventually, if you try enough times, you'll find that the message is received. You'll see that the channel is test and the message is foo. So why is it not working consistently? Well, the answer is if you look at the code, this client registration actually happens asynchronously. So first up, this means that the publish function can fire. But at this time, since the subscribe and the subscriber.on function is actually registering in the background, it's not configured totally to receive that message yet when the publish happens. So to demonstrate, we can set a delay on this publish to make sure that all of this subscription and registration finishes before the publish actually occurs. We can use the setTimeout method to create a callback that calls testPubSubPublisher.publish. And then we'll set a delay of 1,000 milliseconds as the second parameter to the set timeout. And this is equivalent to 1 second. As you save this, head back to the command line and let's try node.pubsub.js once more. We're going to have to wait 1 second for the message to appear. But yep, essentially we do see the message. Great. And this should be consistent. Every time you try, you will see that the message is received, the channel is test, and the message is foo. Now, the really cool thing about this is that we can open up a second command line instance. And if we fire node.pubsub.js again, you wait a second, well, you'll see that that original instance is now configured to receive those messages that are firing based off the second pub/sub implementation. So that's so cool. We can fire as many of these as we want, and that original implementation is going to be ready to receive those messages on the test channel. Awesome. So this is how we're going to configure the peer-to-peer network in our blockchain application. We're going to take advantage of this pub/sub class to add publishers to specific channels that send information in the network. And then we're going to be subscribed to those channels so that way we're ready to receive broadcasted blockchains, etc. So before we move on, let's add a new start Redis script to the package.json file. This will allow us to always start the Redis server when we start up our application. So let's have a new script that says start Redis. And the value for this is going to be Redis server. And then we're going to daemonize and pass the option of yes. And then before we fire the dev command, we're going to make it a requirement to fire the start Redis command. So we have this command npm start Redis, and then we can combine both commands with an and operator. Cool. So this will ensure that Redis gets a chance to start every time we want to run the application. All right, let's extend this basic Redis pub/sub class now in order to support a suite of functions related to multiple blockchains interacting.